Hello, grade 12. Here is Mr. G, and we're going to be doing another video on organic chemistry. This is going to be a question. It's a question from previous question papers. I don't really remember which one, but it's one of them. Okay, and this question is relating everything about organic chemistry done up until this point in terms of naming compounds, isomers, type of alcohol, hydrocarbons, etc. Okay, so the question says, and I'm going to go slow so you can pause the video and try to do the question before. The letter A to H in the table represent 8 organic compounds. Then you have A and B. Then you have C. Then you have D, E, F, and G. Alright? And H. You have also H. So the question, let's start with the question. Write down the letters that represent a compound with a carboxyl as a functional group. Now, before I do that, let's quickly go here and find out the functional group real quick, and then identify the homologous series. So for compound A, this is the functional group, and you can see this, an alcohol. Okay? Compound B, the functional group, you can see it here at the back. That is the functional group, and you can see it is an aldehyde. This is an aldehyde. Compound C, we cannot see clear what is the functional group. We're going to just look at that one a little bit later. But compound D, you can see it finishing ane, and you can see halogens here. So this one is a haloalkane. It's a haloalkane. You go to compound E, and you can see that finish in oic acid. So it is a carboxylic acid. Compound F, like compound C, we're going first wait a little bit. We're going to compound G, we're going to do the same, and compound H, it is finishing in on, and therefore is a ketone. Let's fix that word here, and let's write it properly. Sorry, is ketone. Right? So now we have 3 compounds we didn't identify. So they are in condensed structural formula, could be a little bit tricky to identify. So let's first of all, before we start answering the question, let's write down the structural formula for those compounds real quick. Okay? So I will write the whole equation there, and then I will come back to you. Okay? Here is compound C. So let's do the structural formula for this compound. Let's write the structural formula for this compound. Alright, so we can see here that we have 2 CH3s. We have 2 CH3, and thus those 2 CH3 are connected to 1 carbon. So you will have a carbon here that have 2 CH3. One, I'm going to do it there, and the other one I'm going to do it at the bottom. This doesn't really matter where do you going to place those CH3s, okay? And this carbon is also connected to 1 hydrogen, as you can see there, so I'm going to do it on top. So this is the first part up until there, okay? Now it's coming another carbon which is connected to a hydrogen. This carbon is connected to a hydrogen and is connected to another carbon. Alright? It's connected to another carbon, and that carbon have a branch of 3 H's. I'm not going to do the bond between the carbons just yet. Okay, so we are here. This is where we stop. Now we have a carbon that have 1 H there. You can see it here. That is what I draw there. And a carbon then that is connected to a alkyl group. Okay, so now I am going to do the rest of the bonds there. Let's see. We have, for this here, we have 1, 2, 3, and 4. For this carbon, we have 2, 3, and 4. Each carbon must have 4. For this one here, we have 2, 3, 1, 2, 3, and then the 4. And this one we are now right here. A carbon with 2 H's. And then CH3. let's just write all the H's in a structural form. But note, this is not part of the question. However, it's a good step to practice, as well as to understand better what is the homologous series. Now, if you do that, you can see this have a double bond, and therefore it is an alkene. So compound C is going to be an alkene. Alkene, which is unsaturated hydrocarbon. I think this is the first important thing to do. So let's do the same for compound F and for compound G. All right, here we have compound F. All right, so let's try to draw or to write the structural formula of this compound. Remember, this is for the study purpose, okay? So you don't have to do it. Actually, the question doesn't ask, but for study purposes, it will be a good step. So we have one carbon that have connected to 3 hydrogens. Then we have another carbon. Once more, I am not going to draw the bonding between carbons just yet. So it's a carbon, there is another carbon, and there is another carbon with one H, and you can see this bracket means a branch. So that branch is connected to this carbon here. Alright, so I'm going to do it at the bottom. We have 2 carbons. You can see there, 2 carbons there, and we have 5 hydrogens. 1, 2, 3, 4, and 5. Then we have another carbon with 2 hydrogens. We are right here, and then finally we have a carbon with 3 hydrogens. Now we can connect all the carbons. We can now draw all the bonds between the carbons. Remember, each carbon must have 4. So the first carbon have 3, and 1 is 4. The second carbon has 1 and need to have 4. 1, 2, 3, and 4. The third carbon will have 3 and 1 is 4, and then the rest is just easy. So now that we did that, we have here the triple bond, therefore the compound is an alkyne. So let's write it here. This is an alkyne. Alright, so let's do the same with compound G. Remember, this is once more for study purpose. Okay, so let's do the same for compound G. Okay, so here we have compound G. So compound G, we have 2 CH3s as the previous one connected to 1 carbon. Okay, so it is 1 carbon, and then you have 2 CH3. I'm going to do one next to it, and I'm going to do one at the bottom. It could be one at the bottom and one on top. It does not really matter. And this carbon here is connected to 1 hydrogen as well. Alright, then it's coming a carbon with 2 hydrogens. Then it's coming another carbon with 1 hydrogen and 1 branch. Remember, the brackets mean a branch. H3, H3, and H3. Then it's coming another carbon with 2 hydrogens and another carbon with 3 hydrogens. Okay, so let's complete the hydrogen. I don't like to leave the formulas incomplete. And now we just complete the bonding between carbons. So the second carbon here has 1, 2, 3, and 4. 1, 2, 3, and 4. And then is the complete structural formula for that specific compound. We only see a single bond between carbon atoms and hydrogen, so is an alkane. So let's go back here for compound G, and it's an alkane. So now we know already what is the homologous series to which each compound belongs. That is very, very important. Okay, so let's go to start answering actually the questions. Question 1.1 said a compound, write down the letter of the compound with a carboxyl as functional group. Okay guys, this one is quite easy. Carboxyl is the functional group of this specific compound they mentioned. Carboxyl is related by name to carboxylic acid. So it's called carboxylic acid because the functional group is called carboxyl. So which one is the carboxylic acid here? If we did this one, then everything will be easy. So it will be compound E. So let's go to solution on 1.1.1. This one is now 1.1.1. The answer is compound, we said, sorry about this one, it is going to be compound E. Compound E is a carboxylic acid. The functional group of a carboxylic acid is called carboxyl. So that is the answer, and obviously you will get 1 mark for that one. The answer there is 1 mark. Okay, so let's go to 1.1.2. 1.1.2, they said which one of the compound is an alkene. If you go there, then we know that the alkene is the compound D. D is alkane, is compound C. Alright, so we are going to compound C. That is the answer for 1.1.2. 1.1.2 is C. That is the alkene. And obviously it will be 1 mark for saying alkene. Okay, let's go to the next one. 1.1.3. 1.1.3, which one is an aldehyde, and we already did that one. So the aldehyde was the compound B. Alright, so we said compound B is the aldehyde. So the first question was actually answered as we were looking for the homologous. So 1.1.3 is compound B, and you will get 1 mark for saying that. Okay, so let's go to 1.1.4. 1.1.4, they say a saturated hydrocarbons. Remember what means saturated. Okay, so saturated are the compounds that only has single bond between the carbon atoms. So we're looking for atoms or hydrocarbons that have only single bond between carbon atoms. Those are the saturated. So we're looking, in other words, for the alkanes. The alkane here was compound G. Compound G is the alkane. Okay, so 1.1.4, the answer is G, and then you will get 1 mark for that answer. Okay, so we're going to 1.1.5, 2 compounds that are functional isomers. Okay, so we're now looking for functional isomer. There is a video related functional isomer. I recommend you to go there and record quickly, but very fast. We're going to go here and write something very quick about functional isomers. So question 1.1.5. remember, you don't have to do this, you can just go straight, but let's write here the small recording. Okay, functional isomer, what are they? Compounds with the same molecular formula but different functional group. This is just a record. Alright, so what are we looking for? There are 2 combinations. If you go back to the video, the combinations are ketones, an aldehyde, and carboxylic acid, and esters. Now, what does it mean? Doesn't mean that they are equal. This is not the equal sign. This means that they are functional isomer of one another. So if you're looking for a functional isomer of a ketone, you must get an aldehyde. If you're looking for a functional isomer of an ester, you must look for a carboxylic acid. So that is what it means, that symbol there at the bottom. So we're looking either of those combinations. If we are here, for example, compound A is out of the list because it's an alkene. Compound is an alcohol. Compound B is an aldehyde. So an aldehyde that in actual fact has 1, 2, 3, 4, 5, 6 carbon. So this aldehyde have 6 carbon. We are looking for a ketone that can has 6 carbon. Alright, so let's see if we have any ketone there. Alright, we have a ketone which is the last one. So let's first of all write the structural isomer for this ketone just to be sure. Okay, just to be sure. So let's do that. here we are with this ketone. Now this ketone is pent. Remember, pent is 5. So we have 1, 2, 3, 4, and 5. The functional group is in the second carbon. So if I'm starting from left, this will be my second carbon. This is all the functional group of a ketone. Then I'm going to connect now all the carbons, and we have in carbon number 4, we have a methyl. So starting from left, 1, 2, 3, 4, here we have a methyl. So this is the structural formula of this compound. The question doesn't actually ask you to draw or write the structural formula, but it will be a good practice to do it, and will give you a better idea. So we have now a ketone that has in total 1, 2, 3, 4, 5, and 6. So we have 6 carbon, and if we count the hydrogen, we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens, and we have 1 oxygen. So we're looking for this one, right? Here for the aldehyde, then there were here on this corner, we have 6 carbon. If we count the hydrogen, we have 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 hydrogens. 12 hydrogens and 1 oxygen. So compound B and compound H are actually functional isomers. So we're looking for compound B, and H. Those are functional isomer. Okay, but now let's first, before we carry on, look if there is any other possibility, any other combination. Now that we don't have more ketones, the other possibility is carboxylic acid and esters. We do have a carboxylic acid here, but we don't have an ester. So the answer is then B and H. All right, that is the answer. If you do this question correct, then you will get 1 mark. Yeah, there's 1 mark for question 1.1.5. okay, let's go to question 1.2. Write down the Iupac name of compound B. So compound B is the aldehyde we already have. Let's just write it there so we can quickly name this compound. So here is compound B. Let's follow the step but real quick because we make videos on this one already. So we already identify it's an aldehyde, and therefore the compound will finish in al. Okay. Second step, we're looking for the longest continuous carbon chain. You can do all the possible ways, but the longest one is this one. There's also an option to go straight, but that one will have only 4 carbons. Okay. So we're taking this one that is turning there. Okay, so we have 1, 2, 3, 4, and 5, and 5 is pent. But remember, for aldehyde you have to add the AN, so it's pentan, right? The other step is to write down the number of the carbon starting from the N nearest to the functional group. Remember, aldehyde, the first carbon is always within the functional group, so it's 1, 2, 3, 4, and 5. And then for aldehyde, we don't have to write in which carbon is the functional group because it's always going to be in the first one. The next step, you identify any substituent. Here we can see that we have a methyl, and that methyl is in the 3rd carbon. All right, so writing down what we have 3 methyl. If you combine the name now, the substituent first, so the name is going to be, write it here at the bottom, 3 methyl pentanal. So 3 methyl pentanal. That is the name of this specific compound. Alright, so if you do that, you will get 2 marks. 1 mark for the first part and the other mark for the final part. Those are 2 marks here. Okay, let's go to question 2.2.1. Question 2.2.2, sorry, compound F. Now we go here, compound F. Remember, we have compound S, the structural formula here. Somewhere, compound C, compound F is here. So we're going to use the structural formula to name compound F, okay? And this is an alkyne. Remember, we already identified the homologous series, okay? All right, so here is compound F. We know the compound is going to end in -ine because it's an alkyne. Alright, that is the first one. There is the triple bond. Second, you look for the longest continuous carbon chain, and we have two options here. This is one option, and this here is the second option. So in the first option, the green one, we have 1, 2, 3, 4, 5, 6, and in the second option we have 1, 2, 3, 4, 5, 6. So either of them have 6, therefore they select the straight one. So 6 is hex. So it's going to be hex, just hex. The next step, you are going to count the carbon starting from the end nearest to the functional group. So if we're starting from this side, we have 1, 2, 3, 4, 5, and 6. So we have the 6 carbons there. Now we are going to go back to the functional group, and we're going to write in the place where the functional group is allocated. And the functional group is in the second carbon, so it will be 2-ine. Alright, then we are going to identify the alkyl group, the substituents. Here we have a substituent on this side. Here is a branch, and this is a ethyl, and that ethyl is in the carbon number 4. So we have 4 ethyl. That is the only substituent we have. So we can actually now write the name. Let's write the name here at the bottom using the information we have. We have 4 ethyl hex 2-ine. That is the name of this specific compound. Okay, 4 is ethyl hex 2-ine. All right, I hope it's quite clear. There is a video on looking at the step of that one. We're going now to the question 2.2.3, compound G. Now compound G is this one here. It's an alkane. We already have the structural formula for that one. Compound G is right here at the bottom, so we're going to use the structural formula that we wrote here to write the name of this specific compound. Okay, so here is the compound. Now we know it's an alkane, and therefore we'll finish in ane. Alright, we already identified the homology series at the beginning. Now we're looking for the longest continuous carbon chain, and we have different options here. The first option is going to be straight, and that one will have 1, 2, 3, 4, 5, and 6 carbon. The second option is going here to 10, and that one will have 1, 2, 3, 4, 5, 6 carbon as well. So the first one have 6, and the other option is going to be, for example, going here. If you do that, you have 1, 2, 3, 4, 5. So it's shorter, not good. And the other one is now going from here there, and that one will have 1, 2, 3, 4 is shorter. So 6 is the longest one. 1, 2, 3, 4, 5, and 6. Okay, so 6 is going to be hex. So we have that one. Now we're going to count the carbons starting from the end nearest to the functional group. However, here we don't have a functional group, so we're going to start from the end that have or is closer to any alkyl group. There is some calculation that sometimes need to be done. Eventually we'll see those examples. This one is not the case, so we're starting from here. 1, 2, 3, 4, 5. Sorry, that is not the 5. 5 and 6. Okay, so those are the carbons, and then we are going to identify any alkyl group substituent. Now here we have one alkyl group, and here we have another alkyl group. They are methyl. Both of them are methyl. So this is 4-methyl, and this one is a 2-methyl. 4-methyl, and you have a 2-methyl here. Okay, so now we have to combine because we have 2 of the same. So you're going to write 2,4 dimethyl. Right, now if we combine all the information we have, the answer will be 2,4 dimethyl hexane. So 2,4 dimethyl hexane. That will be the answer. And as before, you will get 1 mark for saying this part here and 1 from the last one. Okay, so I hope this one is clear. It's not that difficult, and let's carry on with the question. We are now for question 2.4. I think we already answered question 2.4. Let's say write down the structural formula of compound D for 2 marks. Compound D is, no, we did not answer that one. Compound D is in what? So let's write down the structural formula for compound D. Here is the compound. We know the compound is a haloalkane, and we need to start now from but. But is 4. So we're going to write the 4 carbons straight line there. Okay? Let's perhaps move all these carbons a little bit down, and let's do it somewhere there. So now what we have? We have 4 carbons. In carbon 1 and carbon 2, I have bromos. So it will be Br, and it's going to be Br. In carbon 3, I have a methyl. It doesn't matter if you do it on top or at the bottom. And then it's just to complete the bonding for carbon and the hydrogen. So all the carbon have single bonds here. We have here hydrogen, hydrogen, hydrogen there, hydrogen there, there, and there. So this is the structural formula for compound D. Okay, so now we're going to question 1.3.2. Sometime I think by the novel I wrote question 2 instead of question 1. That is not a big problem. Okay, so you just fix the numbering and then write down the structural formula of compound H, and that one, yes, that one we already also didn't do it. It's with a name. Compound H is 4-methyl pentan 2-on. Oh yes, we did it, but it was in the question of isomer. It's compound H. There is compound H, the structural formula. So that is the answer. I'm not going to redo it. It's question 1.3.2. So this was all the question. I don't think it's that difficult. I'm very sorry the video is long because the question is long. It's a lot of work and I wanted to go through everything. But thank you very much, and I'm very sorry for making such a long video, but the question is long. So this more or less is what you are going to get in the exam, in the upcoming exam for control test, or later on June, September, and end of the year. Good luck. Thank you for watching, and leave a comment if you have any question or any suggestion. Okay, thanks a lot.